Right, so we're going to explain in this video the other form of writing complex or representing complex number. So the forms that we've been using so far, it's called the rectangular form. When you have the real parts and the real components, this form is polar form when you're going to use the argument and the modular. We've spoke about the argument and the modular previously. So the different form, the rectangular form, just using the coordinate, which is the real components, and the imaginary components. The polar form, it's the angle. You need the angle and the distance. The angle is the angle between the real component positive the positive real axis all the way anti-clockwise to the vector. That's the theta, or that's the argument in there. And the distance is the modular. So the angle is our argument and the distance is the modulus. We're going to learn how to convert between both rectangular to polar form or from polar form back to rectangular. So for example, here we've got a complex number. It's in the polar form, in the rectangular form, the real components and the imaginary components. So that's our argument, which is from the real axis anti-clockwise to the vector, or to the vector of the complex number. And R, that's what you need also, the modular, which is you're going to use Pythagoras to find the modular, as we've discussed before. And you use tan or ratio. You can use tan, cosine, or sin, any trig ratio of the right angle triangles. You can use them to calculate theta, but I always prefer to use the tan. The only reason, because in the tan you don't need the hypotenuse, which is something that you've calculated yourself. So just in case if you make a mistake in calculating the modular, that mistake does not carry over. That's the only reason, but you can use sine and cosine. Sometimes there are some ambiguous cases where the sine of them, if you do cosine inverse of an angle of a value, give you different than the sine inverse. So they give you different value, different angles, but that's not quite often. So anyway, I use the tan most of the time. So we need to find r and theta here. So you've got the modular here. So you've got the modular. To find the r, you can use the theta. Tan, you can use sine or cosine the theta to find the theta itself. Now, how we can convert from polar back into the complex number? So what is the real part in the complex number in the rectangular form represent, and what is the imaginary parts? Now the real parts in the rectangular form represent cosine, r cosine theta, and the imaginary part is r sine theta. So you can see this y is the imaginary component and it's equivalent to r sine theta, and the x, which is the real part, it's actually r cosine theta. So this is how you can convert. If you know the theta and the r, you can convert it back to rectangular. So we can convert from rectangular form to polar form just by finding the modular and the argument. Only by finding the modular and the argument you can convert. And you can, if you know the modular and the argument, you can use this equation here, which is r cosine theta plus I r sine theta, to convert it back into rectangular. So to write the rectangle, if you know the r, if you know the theta, you can write it as a polar form. You only need r cis theta. So this z is the same complex number, but it's in the polar form, r cis theta. Okay, if you know the theta and the modular, you can write it back into the rectangular by kind of expanding it. R cosine theta plus I sine r sine theta. Okay, so it's just kind of expanding it. So let's take an example. So you've got you've got the complex number in here, 3 plus 4i. As we said, to write it into polar form, we need the theta and we need the modular. So we're going to calculate the modular using Pythagoras. We're going to calculate the theta using the tan. So tan inverse 4 over 3. It gives me 53.1 degrees. So to write the rectangular complex number 3 plus 4i into polar will be 5 cis 53.1. That's it. That's if you want to write it as in degrees, and this one if you want to write it in radians. I do prefer that when you write it in radians, you actually write it using the pi, not a decimal point. If that's possible for you, obviously, you can convert it. So the steps to calculate is you sketch it first. To convert from rectangular to polar, you sketch it, you find the modular, find the theta, and then you check the coordinate and apply the rule. Why you do check the coordinate and apply the rule? So when you sketch it, you will be able to know where is your complex number. In the first coordinate, first, second, third, and fourth coordinate. Okay. If it's in the first coordinate, then the theta that you're calculating using the tan or the cosine or the sine, whatever you prefer, is the same theta that you're going to use for cis. So that's your actual argument. But if it is in the second coordinate here, then the theta that you're calculating is actually over here. This one here, the angle that you're calculating using the sine and cosine. But the theta or the argument for your complex number, it's from, remember, it's from the real components anti-clockwise to the vector. So that's why you will have to do 180 minus that theta. And if it's in here, then you'll have to do 180 plus the angle that you calculate. And if it's in here, you're going to do 360 minus the angle that you calculate. So you will have to be able to know which rule you're going to use. You can't just use the angle as you calculated it. So for example, here. So you've got the complex number 3 minus 3i. Now, first you sketch it. So when you're sketching it, you can see it's in the fourth coordinate. So you know the theta that you're going to calculate, you'll have to do 360 minus that theta. So using the modular, using the sine or cosine to find the theta. So you can use the sine, cosine, you get pi over 4, or you can use the sine rule, also you get pi over 4. So the angle is pi over 4. So that means that you have to do 360 minus pi over 4, and because we're dealing with radians in here, so we will do 2 pi minus pi over 4, so the answer will be 7 pi over 4. So you can either write your complex number as r cis pi over 4, that's the positive angle, or if you want to use the pi over 4, which is the clockwise. Remember the argument, the positive argument is anti-clockwise. Now, if you use the clockwise, that means you will have to do negative pi over 4 because you're going opposite direction. Okay, so that's your polar form. Next questions, negative 4 minus I. So you're going to use the r or the modular. So this is on your third coordinate. So you know you will have to do 180 plus theta. Now you've got your modular. Calculate the modular first. Then you're going to calculate using sine or cosine to calculate the theta. So you're going to calculate the theta here. You get theta inverse, which is theta 0.245. Obviously, that's in radians. Now, in radians, because we're dealing with radians, then you'll have to do pi plus. That's give me the angle in radians. Then writing it will be just the modular cis the angle in radians. You can use degrees, then it will be 180 plus that. Now, how to convert from polar to rectangular? Actually, polar to rectangular is way easier. You just need to use r cosine theta for the real components plus r sine theta for the imaginary components, and whatever angle you get you values, normally you get decimal values or fractions, whatever, you just write them as they are. So for example, in here we will have to do 2 cosine negative 5 pi over 4 plus I sine negative 5 over 4, and then you get the answer in here in decimals.